Single mode fiber is the backbone of our current optical networks, and it's been around since the early 1980s. But nowadays, everyone is talking about hollow core fiber. What is it and what makes it so special? If you want to find out more, stick around and we'll check it out. With single mode and multi-mode fiber, we have a silica glass core. And around that core, we have got a silica glass cladding. But the cladding has got a higher refractive index to make sure that the light stays within that core. With hollow core fiber, as the name already implies, well, we've got a hollow core. In other words, we're pretty much sending the light through air. And to make sure that the light stays within that core, we've got this highly engineered microstructure silica glass cladding. Now, the fact that we're actually sending light through air and not through the silica glass itself, well, that makes a big difference. Let's start off by having a look at the latency. If we have a look at the speed of light in vacuum, well, then we're talking about roughly 299,792 kilometers per second. But if the light is not traveling through vacuum, but through, for example, glass or air, it is actually traveling at a slower speed. And the higher the refractive index is of the medium that light is passing through, the slower it actually gets. So if we have a look at the speed of light in an SMF28 single mode fiber cable, you will see that it's at roughly 204,225 kilometers per second. Hollow core fiber is at roughly 299,705 kilometers per second. That is significantly faster. As a matter of fact, it is more than 32% faster. So what good does that do? Well, if we have a look at high data rate and low latency applications, so AI data centers or high-speed trading, just to name a few of them, 32% faster, that is a big difference. Another advantage of hollow core fiber is when we have a look at the attenuation, because if we have a look at the single mode fiber, we've got two main reasons. Number one being the scattering or the Rayleigh scattering, meaning that the light is actually interacting with the microscopic impurities of the fiber and some of the light is being scattered out of the core. And the other reason being the absorption. In other words, the silica molecules, they're actually absorbing some of the photons and basically are converting them to heat. Now, for hollow core fiber, we also have attenuation, but a different type. So the first type of attenuation we have with hollow core fiber is the so-called leakage attenuation, meaning that a fraction of the light is actually leaking through the structure of the hollow core fiber. And the other attenuation that we have is also a scattering, but the scattering happens here at the surfaces of the structures because they aren't 100% smooth. But the point is, the difference in attenuation between single mode and hollow core fiber is 50%. So hollow core fiber has a 50% lower attenuation than single mode fiber. And that means we can reach much greater distances with hollow core fiber with the same amount of optical power. Now, there are many more advantages of hollow core fiber compared to single mode fiber, but if I go into all of them, this video will get far too long, so maybe it's for another brain snack video. So does that now mean we're only going to be deploying hollow core fibers all over the world now because it's so many great advantages? Well, no, because we do still have some challenges. Since the hollow core fiber, the structure is much more complex, that also means that the manufacturing is also much more complex, meaning that at the moment, hollow core fiber is still quite a bit more expensive than single mode fiber. Also, if you want to have a low loss splice for hollow core fiber, then you need to have specialized splicing equipment. And also, when you cleave a hollow core fiber, so unlike with a single mode fiber, you actually need to seal the end of the hollow core fiber. And last but not least, the mode field diameter of the hollow core fiber is much bigger than that of a single mode fiber. But the point is that all the high-speed equipment out there is based on single mode fiber. So they're expecting a mode field diameter of single mode. So in other words, we need a conversion of the mode field diameter between hollow core fiber and single mode fiber. But the point is, because hollow core fiber has got so many great advantages, the development cycles also tackling these sort of things are extremely fast. And we're at the early days of hollow core fiber. As a matter of fact, at HUBER+SUHNER, we actually have a patented LC connector for hollow core fiber that takes care of that mode field diameter conversion between hollow core fiber and single mode fiber. So in other words, with this connector on your hollow core, you can interface directly with single mode equipment. So, I hope you learned something today and that you enjoyed this video. If so, please leave a comment. And of course, if you have any further questions regarding hollow core fiber, please also drop them into the comments and we'll answer them. And last but not least, please remember to follow our channel so you get your regular dose of brain snack. Until next time, bye-bye.